Now let's start with the new topic of the parallelogram law of addition of vector. Law of addition of vector. Let's the two vector are a vector and b vector. Represent the adjacent sides of the parallelogram. Now let's draw a parallelogram. Now parallelogram A, B, C, D. Now the AB, that is represent to A vector, BC is the B vector, and the diagonal AC is the C vector. Now in triangle ABC, now in triangle ABC, AB vector plus BC vector. Now meaning of this, now move A to B, then B to C. Now the A to C is the displacement from A to C. Now the AB vector plus BC vector is equal to AC vector. Now the C vector is equal to A vector plus B vector. Now in the parallelogram the opposite sides are parallel, so now it is A vector, so it is also A vector. Now it is B vector, so it is also B vector. Now the diagonal AC is A vector plus B vector. Now the triangle law. Now the triangle law of the addition. It's a triangle A, B and the C. Now it's the initial point. Now start, move A to B, that is A vector, B to C is B vector. Now the displacement is C vector from A to C. So A B vector plus B C vector is equal to the AC vector. So A vector plus B vector is equal to the C vector. Now the properties of addition of vectors. Now the first one is commutative. Now commutative means now add the A vector plus B vector now is equal to the B vector plus A vector. Now second one is associative. Associative means let's consider three vector A vector, B vector and the C vector. Now add the three vectors. First of all add the A vector and B vector, then add with the C vector is equal to the A vector plus add with the B vector plus C vector. Now the third one is existence of additive identity. For every vector A vector plus null vector is equal to the null vector plus A vector. Now fourth one is existence of additive inverse. Now meaning of the additive inverse is the now a vector is add with the another vector and the resultant should be null vector. So now let's the A vector. Now if I add with the another vector then it will be the zero vector. So the additive inverse of A vector is minus of A vector. So A vector plus minus of A vector is null vector. So additive inverse of A vector is minus of A vector, or the additive inverse of minus A vector is A vector. Now the next point is subtraction of vectors. Now again draw a triangle first thing. Now O A B. Now OA represent to A vector, AB represent to B vector, then it resultant A vector plus B vector. Now the subtraction of b vector from a vector is defined as the vector sum of the a vector and the minus of b vector. Now if we define the b vector from a vector, so now the take the b vector is in this direction. Now it's a point C. So it is opposite direction, so that is minus of b vector. Now the resultant of OC, now that is OC is a vector plus minus of b vector. That is resultant is a vector plus minus of b vector. Now it is a subtraction of vectors. Now for in a triangle, a vector plus b vector plus c vector is equal to 0. Now let's see, is it true or no? Now the AB vector is represent to a vector, BC is represent to b vector, and the CA is represent to c vector. Now by the law of the addition, AB vector plus BC vector is equal to the AC vector. Now the AB vector is a vector, BC vector is b vector, and the AC vector. Now here the AC vector means, but the point is moving C to A. So AC vector is the minus of C vector. Now transferred to left side, A vector plus B vector plus C vector equals to 0. Now if the A vector, B vector, C vector be represented by the sides of a triangle taken in order, then the A vector plus B vector plus C vector is 0. Now let's take the example. If A vector and B vector are the vectors determined by two adjacent sides of a regular hexagon, what are the vectors determined by the other sides taken in order? Let's solution. Now the first of all thing, draw a regular hexagon. Now the meaning of the regular hexagon is the all sides are equal. Now A, B, C, D, E, F. Now we need to find all the adjacent sides in the vector form. Now let's consider the AB vector initially represent to A vector and the BC vector is represent to B vector. Now first of all join the A to C. Now first of all join the A to C. Now by the triangle law, AB vector plus BC vector is equal to AC vector. So C vector is equal to A vector plus B vector. Now the AC vector. AC vector is A vector plus B vector. Now it's a regular hexagon, so it's a CD vector. Now join A to D. Now the AD is parallel to BC. Now the AD is parallel to BC. Why? The DC is equal to the AB. Now so this line is parallel to this line because it is a regular hexagon. So AD is parallel to BC. Now such that AD is 2 times of BC. So AD vector is 2B vector. Now in triangle ACD, AC vector plus CD vector is equal to AD vector. So now the CD vector is equal to AD vector minus AC vector. It's 2B vector minus of A vector plus B vector. So it is B vector minus A vector. Now AD vector is B vector minus A vector. Now clearly the DE vector. So now clearly DE vector is minus of AB vector. Minus of AB vector because these are again parallel. So it is minus of A vector. EF vector is equal to minus BC vector minus B vector. F A vector is equal to minus of CD vector. So it is minus of B vector minus A vector. So A vector minus B vector. Now let's take the next example. For any two vector A vector and B vector, prove that magnitude of A vector plus B vector is less than equals to magnitude of A vector plus magnitude of B vector. Second is magnitude of A vector minus magnitude of B vector is less than equal to magnitude of A vector plus magnitude of B vector. Now the solution: draw a triangle. Triangle is OAB. Now it's A vector, B vector. So OB vector is a resultant vector, A vector plus B vector. Now in a triangle we know that the sum of the two sides is always be greater than to third side. We know that the sum of the two sides is always be greater than third side. So OA plus AB is greater than OB. Now OA is the magnitude of A vector, AB is the magnitude of B vector is greater than OB is the magnitude of A vector plus. Now in this question the one thing is also given, the equal to sign. Now if they are collinear, suppose if they are collinear, now like in this condition OAB, so in that condition A vector plus B vector is equals to the magnitude of A vector plus B vector. So if they are collinear, so magnitude of A vector plus magnitude of B vector is equal to the magnitude of A vector plus magnitude of B vector. So now it's proved the magnitude of A vector plus magnitude of B vector is less than or equals to the magnitude of A vector plus magnitude of B vector. Now the second part, similarly, now the magnitude of A vector minus the magnitude of B vector is less than equal to magnitude of A vector plus, we can write like as a magnitude of minus B vector, because the magnitude of negative quantity is always be signless, so we can write like in this form. Now in left hand side it's also we can write A vector plus of minus B vector. It should be A vector plus minus of B vector. So it is magnitude of A vector plus magnitude of B vector, because the magnitude of minus B vector is equal to the magnitude of B vector. So this result is also true. Now in the next lecture we will continue with the multiplication of vector by a scalar.